a tricky problem. Maybe it's tricky. A polyhedron has 20 faces and 20 vertices. How many edges does it have? Like many problems, the hardest part is just getting started. A polyhedron with 20 faces, what is that? Fortunately, we know we don't have to worry about a polyhedron with 20 faces. Let's just start with one we can draw. How about a tetrahedron? Imagine this in 3 dimensions. The simple cube. Now, we can count the faces, the edges, and the vertices for these simple polyhedron. Let's see if it leads us anywhere. The tetrahedron, how many vertices does it have? Well, we can see that there's just 4. The cube, we can count them. There's 8. What about edges? On the tetrahedron, I can see that there are 1, 3, 4, 5, 6 edges. I can count the lines. The cube has 12. Count them yourselves. Faces, on the other hand, it's hard for me to picture something in 3 dimensions when I'm looking at it in 2. So it helps to kind of go through them one by one. The faces of the tetrahedron. The front, the side, another side, and the bottom. Just 4. What about the cube? A side, back, side, front, top, bottom. 6. Now here's the key part. Can we infer any pattern from these numbers? And you have to play around with it a bit. It helps to know that there is a famous formula behind all of this. For example, if I took vertices plus edges, I get 10 for the tetrahedron. Is there any relationship between 10 and 4 faces? No, that doesn't make any sense. How about vertices plus faces? 8 minus edges, 6, that leaves me 2. Let's hold that thought. Vertices plus faces minus edges equals 2. Try it with the cube. 8 plus 6 minus 12 equals 2. Yes, it turns out that's our famous formula. V plus F minus E equals 2. It's actually called Euler's formula. Very famous formula. But I always confuse it or get something wrong. Therefore, if a polyhedron has 20 faces and 12 vertices, and if our general formula is V plus F minus E equals 2, then I know that 12 plus 20 minus E equals 2. Or 30 equals E, the number of edges of our polyhedron. This famous polyhedron, as an aside, is the icosahedron. For more examples of using this simple thinking strategy to investigate math problems, visit rationalmath.com.